All right. Zooming into database organization. Now, I know, I've been talking about a lot of niche theoretical topics, and we really haven't zoomed in on any practical things. But again, what we're trying to do is give you that foundation, that foundational knowledge that will help you throughout your career. Now, when we look at databases, we often have many tables, many views, and depending on how much you care, you may want to organize them in a logical way, kind of like sweeping. You don't want things to be cluttered and dirty. You want a method to the madness, so to speak. What we talk about in Postgres are called Postgres schemas. This is a construct in Postgres. It's a concept. And you have to think of it like a box, right? You have to think of it like a box in which you can organize things. And so over here, you can see 4 boxes. And these 4 boxes represent 4 different schemas. And in these boxes, we can organize tables, views, indexes, types. We can basically say, hey, these are separate from each other. And why would we want to do that? Well, let's say we were creating a database structure for a company. And we had a sales department, a marketing department, all of these other different departments. Are we going to create a database per department? No, all the data needs to be intermixed so that we can kind of select and pluck data and query effectively among that one database. Why would you go and split that prematurely? That sounds like a lot of work, creating a database per organizational unit, so to speak, per department. No. That's not what we're going to do. We're going to organize the tables, the views, and the indexes in schemas. And so we can create a schema called sales. We can create a schema called payroll. We can create a schema called HR and technology and engineering and all of the different departments that you want. You can structure it any way you want. It doesn't even have to be by department. You can just create these constructs of boxes in which you put things. By default, each database gets a public schema. So when you create a database, you have that public schema. That is the schema that is available to every other schema. And it is the one that will be called by default. It is the one that, is assumed to be the default schema whenever you're trying to reach a table. So if you have a table in the public schema and you have a table in, let's say, the sales schema that has the exact same name, well, it's going to get the public schema first. That's what it's going to assume you're referring to. And unless you specify a schema, the default is always going to be assumed public. Very, very, very important. It is always going to assume public. Over here, we can see select star from employees is the same as select star from public employees. Public dot is the schema notation. This is how we kind of denote a schema. And so writing public dot is the same as not writing it at all. There is a way to show all the schemas. You can do \dn, and this will show you all of the different schemas that are on the database and who is the owner of the schema, because whoever creates the schema, again, is the owner of that schema. So with \dn, we can see that public is our only schema in the super duper database we created, for instance. And we can create different schemas by using the create schema command. If we created the schema sales, then we would see that we would have a schema sales. And I would say pause the video here and go try this out. Go create a schema. Go create multiple schemas and try out the dn command and see what happens. Now, you may be asking yourself, okay, Mo, I get it. Schemas are like these boxes in which I can organize things, but why would I use them? And this is plucked directly from the Postgres docs. But it's important to know, why would I use schemas? And it's to allow many users to use one database without interfering with each other. So interfering with each other, what does that mean? Well, if we only had a public schema and each department, for instance, needed a table that had the exact same name, well, they would interfere with each other because in one schema, you can't have 2 tables with the exact same name. And what are you going to call it? Table 1, table 2, sales _ table? You can do that, but it's not great. Schemas are a better way of optimizing for this. It's also good to organize your database objects in a logical group, and it makes it more manageable. And then the third one and the final one, if you have third-party applications that need certain tables and data and whatnot, you can put them into separate schemas so that they do not collide with the names of other objects. Again, very important. It's about not interfering with the global data, right? If you separate things into schemas, you can have duplicate names, you can have duplicate named objects that are not necessarily the same because they're in a different logical group, but you're still operating on the same database. And so the question becomes, well, why wouldn't I expand to a different database? Well, because maybe you want to make it easy for yourself to be able to query across the multitude of things that are stored in your database. The only reason that you would go off into a completely separate database is if it's for a completely separate purpose that has nothing to do with the data that you have in your current database. So always reach to the things that make it easiest to manage before you go and do something like creating a completely different database, or as I like to call it, a completely different universe, because you're not going to have any of the data from the other database. And so with that, with schemas out of the way, the one thing that I wanted to zoom in on, it's very easy for us to go ahead and like at willy-nilly, create a database. It's very easy. We run the command and, we're hot shots. We can create databases left and right. Super, super easy, straightforward. Well, creating a database is actually a restricted action. Not everyone is allowed to do it. And so what I wanted to do is I wanted to zoom in a bit on permission management, because that's also important when it comes to databases, when it comes to managing databases. Who is allowed to access what? How do we structure those rules? Because, we set up this database world and, we're a super user. We're an admin. We have like the Superman logo on our chest. We can do whatever we want, but not everyone is allowed to do it in a bigger company, in a bigger scale. There are rules and permissions. And so let's look at how those work in Postgres.